Hello friends, welcome back to our channel Cisco Packet Tracer Labs. In today's practical, we will learn working of DHCP. Launch Cisco Packet Tracer and we will see working of DHCP, which is dynamic host configuration protocol. Go to end devices, select PC, can put few PCs over here. Go to network devices, select 24 port switch, go to connections, select automatic connection and connect all the pieces with the switch. Now, if I want to assign IP address to these PCs, for example, my network range is 192.168.10.0. So, in this case, what I am supposed to do, I will go to PC0, go to desktop, IP configuration, right here 192.168.10 dot, let us start with 10. Subnet mask and the gateway will be 192.168.10.1. This is how we assign IP address to a PC using static mode. But because in this practical the number of PCs are too much, it in this practical these are only 10 PCs are there, we can go for 24 PCs, we can go for 100 PCs, we can go for 200 PCs. Then it is a tedious process and chances of error is very high. To solve our problem or to ease our work, what we do, we use DHCP or dynamic host configuration protocol. Now go to end devices and take one server machine and place it in the work area. Server is a machine which provides you services. Go to connections and connect the server with the switch. Now this is our DHCP server. Okay. Now go to server, go to desktop, IP configuration, assign a static IP address to it. For example, I am assigning 192.168.10. Let's say 100. This is an IP address assigned to this the server. Generally, we assign the servers well-known IP addresses which can be easily learned. For example, 10.100, 100, 200, 150, 50. These are some of the figures which we generally learn very easily. Now, gateway address will be 192.168.10.1. Okay. Now, as I have told you that server is a machine which provides you services, click on the server, go to services and the services select DHCP. Do not forget to turn it on and you will see the first pool name is server pool. We cannot change the name of the default pool name, so it will remain server pool. Now I have to give default gateway address, so it is 192.168.10.1. Now in this network, then it asks for DNS server. Right now we do not need DNS server, so I'm not putting over here. Then start IP address 192.168.10. Let us start from 10 and save. We can also change the maximum number of users. Now it is an example of class C network. In class C, there can be maximum 256 hosts. And as we are starting from 10, so it is not by default, it is selecting 246. So you can see the entire thing over here also. Let me enlarge server pool. Default gateway 192.168.10.1. DNS server is not given. Start IP address is 10. Subnet mask is 255.255.255. Maximum user 246. Now go to any of the PC1. Then I am going for desktop IP configuration. So you can see by default it is static. Click on DHCP. Automatically it is taking 11. Why it is taking 11? Because we have in this PC0 we have already given a static IP address. If I click on 10 is already used. So if I click on DHCP over here, it goes after 11 it goes for 12. Then I click on PC2 desktop IP configuration DHCP 13 and it goes on like this. This is how your DHCP is working. In the next step, we are going to learn the simulation process of DHCP and how actually it works. What are the basic 4 steps in which your DHCP is working? Let us understand the 4 steps of DHCP. So these are the 4 steps of DHCP, which are the first step is you discover, where client broadcasts a request to DHCP server. Second step is offer. DHCP server offers an available IP address. Third step is request. And fourth step is acknowledge. In the request, client requests the offered IP address, and in acknowledge, server confirms the assignment of the IP addresses. In short, we can say it is a DORA process: discover, offer, request, acknowledge. So let us see it in simulation mode. Click on the simulation mode. Show all oblique none. Edit filter. Now, because we have to see DHCP protocol, working of DHCP protocol, click on DHCP. Okay. Now, let us see the process. Please note this step very carefully. I am going to assign IP address using DHCP in PC7. Click on PC7, desktop, IP configuration, and click on DHCP. Now it is requesting IP address. It will be, because we are in a simulation mode, it will not show immediately. Minimize the window. And you can see over here, the packet is ready. DHCP packet is ready. Now, when I click on this, first step, discover. Discover packet is broadcasted to all the PCs, because right now I do not know where is my DHCP server. Now discover packet goes to all the PCs. Only the DHCP server has accepted it and rest of the PCs have not accepted it. Now how does this DHCP server comes to know that it is a DHCP discover packet? Now let us see in detail of this. I am looking at this simulation panel window, drag it and let us see server 0 DHCP packet. Click on this. I will see the entire detail. Okay. Now, because DHCP is an application layer protocol, DHCP is an application layer protocol. Please keep it, remember it, that DHCP is an application layer protocol. Now you can see layer 7, which is an application layer protocol. The DHCP packet is coming, which is DHCP server 0.0.0.0, because no one knows the IP address of the server also, and client is 0.0.0.0, because no one knows the IP address of the PC who is requesting it. Our PC is having one application layer protocol where DHCP client is installed. Now you can see over here, after application layer, it goes to transport layer. In transport layer, it says UDP source port 68, which is your source, means your client. DHCP client, the port address is assigned, which is, yeah, this thing is to be learned. UDP, Universal Datagram Protocol, port number 68 is for client and port number 67 is for DHCP server. DHCP client is 68, DHCP server is 67. Now you can see over here, next is the network layer. In network layer, the source IP address is 0.0.0.0. That means, right, whenever any of the PC is brought into the network and IP address is not assigned to it, automatically by default the IP address is 0.0.0.0. Now this request packet is broadcasted to every machine. That is why destination IP address is 255.255.255.255. Okay. After the network layer comes your data link layer. Now, because as a machine, I know my machine MAC address, but I do not know the MAC address of the server. Okay. Now that's why some MAC address is given over here, source, but the destination it is FFFF, which is all one. Okay. Now let us move to the next step, which is offer. Now DHCP is server offers an available IP addresses, because we have filled the entire range over there in this DHCP server pool 1. Now this offer packet goes to the switch and it is broadcasted to every machine, because server also doesn't know from where the request comes. So it is broadcasted to every machine. So if you see over here in the DHCP server, there we will see it is broadcasted to every machine. Destination is, now this is source IP address, which is the IP address of the server, and this is destination, because we do not know where the machine is. But if you see over here, in this case, from this is changed now. Application layer, offer packet is there. So server address is 192.168.10.100. Client we do not know right now. Then comes to your transport layer. Now it is swapped. Source is 67, which is DHCP server. Client is 68. Now this PC in the network layer, source is 192.168.10.100 and client is 255. And your similarly, server also do not know what is the MAC address of the client machine. So this is MAC address of the server and this is FFFF. Now again, all these PCs has rejected the offer, but only one of the PC has accepted it, which was PC 7, which has initially requested for the IP address. Now next step is your request. Now client, that means PC7, is going to send a request to the offered IP addresses. Let us see. Click on the next. Again, it is broadcasted to everyone, but DHCP server has accepted it. Now this is the request packet. Now from the request packet, you can see over here DHCP server, client, source, transport layer. This is the, you can see this is the in layers when it is coming in. Source is 68, destination is 67. When packet is going out of the server, source is 67, packet is 68. Everything is reversing over here. Okay, you can see. Now the next step is acknowledge. Server is confirming that this IP address is assigned to you. Let us see. Acknowledge packet goes to the switch and it is broadcasted. All the machines have rejected it except the PC7. Now we will see when the, if we maximize the window, you can see an IP address is assigned to it. This is how your DHCP works within the network. I think some of the concepts are clear. So in the next practical where we are going to perform DHCP across the network, all the other things will be clear to you. Thank you friends for watching this video.